Hello friends, in continuation of my previous video in which we discussed about number of squares and rectangles in a grid. Now I had observed some different observations regarding the same pattern, so please have a look on it. So if we are having a number of squares in a grid of 4 cross 4, the number of square as told in the previous video is 1 square plus 2 square plus 3 square plus 4 square, which comes out to be equal to 1 plus 4 plus 9 plus 13, that is 30. I would like to share a different observation, like here 4 square represents the number of squares of dimension 1 cross 1, that is you can count here as 1 1 1 1. Total there are 16 squares. Of dimension 2 cross 2 there are 3 squares. Of dimension 3 cross 3 there are 2 squares, and of dimension 4 cross 4 there are 1 square. That is, the dimension is 1 cross 1, then the total number of squares are 4 square. If the dimension is 2 cross 2, then the number of squares are 3 square. If the dimension is 3 cross 3, number of squares are 4. If the dimension is 4 cross 4, then the number of squares is 1. So the total number of squares becomes 30. And if we are having a grid of n cross n, then the number of squares as told in the previous video are 1 square plus 2 square plus 3 square up to so on n square. Here n square represents the number of squares of 1 cross 1 dimension. N minus 1 square represents the number of squares of dimension 2 cross 2. Similarly, 3 square represents the number of squares of dimension n cross n minus 2 into n minus 2, and 2 square represents the number of squares of n minus 1 cross n minus 1 dimension, and 1 is the number of square of dimension n cross n, the complete square. Here we are having a pattern, that is 1 cross 1 there are n square, 2 cross 2 dimension there are n minus 1 square. That is, if we have to calculate the number of squares of dimension k cross k, then the formula becomes n minus k plus 1 whole square. Thus, if a grid of n cross n is given, then the squares of dimension k cross k are n minus 1 k plus 1 into n minus k plus 1. You may observe that at every stage the sum of the dimension and the number of squares is k plus n minus k, that is comes out to be n plus 1. Like for in this example, 1 cross 1 has n square, so their sum 1 plus n comes out to be, you can say as their sum 1 plus n comes out to be n plus 1. For this 2 cross 2, the sum comes out to be 2 plus n minus 1, that is n plus 1 again. So now if we have to calculate the number of rectangles in the 4 cross 4 grid, then we can see that the number of rectangles are, we know the formula that 1 cube plus 2 cube plus 3 cube plus 4 cube, which comes out to be 4 into 4 plus 1 by 2 whole square. Here we can observe a different pattern, like we can say as 1 plus 2 plus 3 plus 4 into 1 plus 2 plus 3 plus 4. After multiplying this, what we get is, I had just arranged this into a matrix, that is 1 cross 1, 1 cross 2, 1 cross 3, 1 cross 4, 2 cross 1, 2 cross 2, 2 cross 3, 2 cross 4. Similarly, I had observed all the pattern, that is if we multiply 1 by 1, 1 by 2, 1 by 3, 1 by 4 up to so on. So what will the pattern we observe is this matrix which is given in the right hand side. That is, first of all, the diagonal elements represent the number of squares here, like this. These are the diagonal elements, 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4. They represent the number of squares. Now 1 cross 2 represents the number of rectangles of dimension 4 cross 3, and 3 cross 2 represents the number of rectangles of dimension 2 cross 3. Special observation is A44, which is 4 cross 4, is the number of rectangles of dimension 1 cross 1, and A43 is equal to 4 cross 3, which is equal to 12, is the number of rectangles of dimension 1 cross 2, that is 4 minus 4 plus 1 into 4 minus 3 plus 1. Thus we conclude that Aij is equal to I cross j represents the number of rectangles of dimension n minus I plus 1 into n minus j plus 1 in a n cross n grid. we can use the result like this as well. If we have to find the number of rectangles of dimension 2 cross 3 in above 4 cross 4 grid, then they are 4 minus 2 plus 1 into 4 minus 3 plus 1, which is equal to 3 into 2, that is 6 in numbers. So if we add all the above possibilities, then we will get the total number of rectangles. Now if we have been given a grid of n cross n, then total number of rectangles can be found like this: 1 plus 2 plus 3 plus up to so on plus n into 1 plus 2 plus 3 plus up to so on plus n. After making the matrix, what we get is 1 cross 1, 1 cross 2, up to so on 1 cross p, where p is a number which is less than n, up to so on 1 cross n minus 1 and 1 cross n. Similarly, when we multiply 2 by all these number on the second bracket, that is 2 cross 1, 2 cross 2, 2 cross 3, up to so on 2 cross p, and then 2 cross n minus 1 and 2 cross n. Similarly, if k is a number which is less than n in the rows column, then we get is k cross 1, k cross 2, up to so on k cross p, then k cross n minus 1, k cross n, and proceeding like this, we can say that this matrix represents the number of different dimensions rectangles. So the dimension of the above rectangles are given in this matrix, that is n cross n minus 1, n cross up to so on n cross n minus p plus 1, n cross 2, n cross 1. I would like to say that here the symbol 1 cross 1, which is written in the first row, first column, and here in the second matrix it is written n cross n. 1 cross 1 represents the number of squares of dimension n cross n, which are rectangles as well. So 1 cross 2 represents the number of rectangles of dimension n cross n minus 1. Similarly, in the end, n cross n represents the number of rectangles, or you can say number of squares of dimension 1 cross 1, and n cross n minus 1 represents the number of rectangles of dimension 1 cross 2. So what the pattern we observe is Aij is an element in ith row and jth column, that is which is written as I cross j, is the number of rectangles of dimension n minus I plus 1 into n minus j plus 1. Thus, number of rectangles of dimension k cross p in n cross n grid is given by n minus k plus 1 into n minus p plus 1. Here again the diagonal elements are the number of squares. Also, if it is given that A23 is equal to 2 cross 3 in n cross n grid, and we have to find the dimension of the rectangles, then we can write 2 cross 3 as n minus k plus 1 into n minus p plus 1. So 2 is equal to n minus k plus 1 and 3 is equal to n minus p plus 1. Getting the value of k, what we get is k equals to n minus 2 plus 1 and p equals n minus 3 plus 1. So k comes out to be n minus 1 and p comes out to be n minus 2. So dimension of rectangle k cross p is given by n minus 1 cross n minus 2. That is, if A23 is 2 cross 3, then 6 are the number of rectangles of dimension n minus 1 cross n minus 2. So let's say now we are having a grid in which the number of squares is different from the number of squares in the rows, it's different from the number of squares in the column. Say we are having the grid of 5 cross 9 dimension now. Here total number of square is given by 5 cross 9, subtracting 1 from 5, subtracting 1 from 9, we get 4 cross 8 next term, then we get 3 cross 7, then 2 cross 6, then 1 cross 5 as discussed in our previous video. So here what I would like to say that 5 cross 9 represents the number of squares of dimension 1 cross 1. 4 cross 8 represents the number of squares of dimension 2 cross 2. 3 cross 7 represents the number of squares of dimension 3 cross 3. And 2 cross 6 represents the number of squares of dimension 4 cross 4. And 1 cross 5 represents the number of squares of the dimension 5 cross 5. We cannot have the number of squares more than 5 cross 5 now in this grid. Thus, number of squares of dimension k cross k is given by the formula n minus k plus 1 into m minus k plus 1. Now again, sum of k cross k and its number, that is n minus k plus 1 into m minus k plus 1, is always n plus 1 comma m plus 1. That is, k plus n minus k plus 1 comes out to be n plus 1 and k plus m minus k plus 1 comes out to be m plus 1. As in the above example, number of squares of dimension 1 cross 1 are given as 5 cross 9. So their sum is 1 plus 5, which is 6, and 1 plus 9, which is equal to 10. So ordered pair is 6, 10. Similarly, the number of squares of dimension 2 cross 2 are given by 4 cross 8, So their sum is again 2 plus 4, which is 6, and 2 plus 8 is equal to 10, again 6, 10. Similarly for others, the required sum is 5 plus 1, 9 plus 1, that is they are of dimension 6, 10. Now if we have to calculate the number of rectangles in this grid 5 cross 9 1, we can write 5 as 1 plus 2 plus 3 plus 4 plus 5, as these are the possibilities of different dimension of rectangles, into 1 plus 2 plus 3 plus up to so on plus 8 plus 9, as these are the different possibilities of getting the number of squares on the column side. So the formula is 5 into 5 plus 1 by 2 into 9 into 9 plus 1 by 2. It gives the total number of rectangles now. So we can write, while expanding this bracket, like 1 plus 2 plus 3 plus 4 plus 5 into 1 plus 2 plus 3 up to so on plus 8 plus 9. We get the matrix as 1 cross 1, 1 cross 2, 1 cross 3 up to so on, 1 cross 8, 1 cross 9. In the second row, what we get is 2 cross 1, 2 cross 2, 2 cross 3 up to so on, 2 cross 8, 2 cross 9. Similarly for the other row as well, we get the total number of possibilities of different rectangles. What we get is, so above matrix are the number of rectangles of the dimension given on the bottom matrix. These are 5 cross 9, 5 cross 8, 5 cross 7 up to so on, 5 cross 5, 5 cross 2, 5 cross 1. It means the number of rectangles of dimension 1 cross 1 are 5 cross 9, number of rectangles of dimension 1 cross 2 are 5 cross 8, number of rectangles of dimension 1 cross 3 are 5 cross 7, and proceeding like this we can say that number of rectangles of dimension 5 cross 9 are 1 cross 1. And you can observe here that the diagonal element from the end, like 5 cross 9 are the number of squares of dimension 1 cross 1, 4 cross 8 are the number of squares of dimension 2 cross 2, 3 cross 7 are the number of squares of dimension 3 cross 3, 2 cross 8 are the number of squares of dimension 4 cross 4, 1 cross 5 are the number of squares of dimension 5 cross 5. Now rectangles of dimension k cross p is given by n minus k plus 1 into m minus p plus 1 in n cross m grid. That is aij is given as I cross j, which is of the dimension n minus I plus 1 into m minus j plus 1 in n cross m grid. So different kinds of problem now we can have. Likewise, how many squares in a grid of 5 cross 9 has area 24 square units? So first of all we just factorize 24 in different parts. Likewise 24 we can write as 1 cross 24, 2 cross 12, 3 cross 8, 4 cross 6, 6 cross 4, 8 cross 3, 12 cross 2, 24 cross 1. What we keep in our mind that the given grid is of dimension 5 cross 9. That is, we cannot have number of squares more than 5 in the rows, and we cannot have number of squares, unit square you can say, more than 9. Okay, so here 24 is greater than 9, so we cancel out this. 12 is again greater than 9, we again cancel out this. In this 6 cross 4 dimension, 6 is greater than 5, so we cancel out this as well. And 8 is again greater than 5, 12 is again greater than 5, and 24 is greater than 5. So we cancel out all these 4 possibilities also. So the remaining possibilities are 3 cross 8 and 4 cross 6 in a 5 cross 9 dimension. So number of rectangles of dimension 3 cross 8 in a grid of 5 cross 9 is given by the formula 5 minus 3 plus 1 into 9 minus 8 plus 1, which comes out to be equal to 3 cross 2, that is 6. And the number of rectangles of dimension 4 cross 6 are given by 5 minus 4 plus 1 into 9 minus 6 plus 1, which is equal to 2 cross 4, that is 8. So total number of rectangles of area 24 in a grid of 5 cross 9 are 6 plus 8, which is equal to 14. You can form a different question as well. Likewise, if we have to calculate the number of dimension of the grid, say if it is being given that the number of rectangles of dimension 3 cross 8 are given to be 12. So what may be the dimension of the grid? Now here we have to calculate the dimension of the whole grid, that is n cross m here. So let the dimension of the grid be n cross m. So number of rectangles of dimension 3 cross 8 are given by n minus 3 plus 1 into m minus 8 plus 1, which is given to be 12 here. That is n minus 2 into m minus 7 is equal to 12. Here the condition is n should be greater than or equal to 3 and m should be greater than or equal to 8. Now we can factorize 12 as in the form 1 cross 12. We can write 12 as 1 into 12 or 2 into 6 or 3 into 4 or 4 into 3 or 6 into 2 or 12 into 1. Likewise, we are having the 6 possibilities here. If we say we have n minus 2 is equal to 1 and m minus 7 is equal to 12, what we have is n can be 3 and n can be 19. If n minus 2 is equal to 2, m minus 7 is equal to 6, then n can be 4 and m can be 13. Similarly, for the other cases, if n minus 2 is equal to 3, m minus 7 is equal to 4, n is equal to 5, m is equal to 11. Now we are getting the different possibilities. Here, we can consider that the rectangle of dimension 3 cross 8 is different from the rectangle of dimension 8 cross 3. That's why we didn't consider that n minus 2 is 12 and m minus 7 is 1. Okay. Sorry, we have taken the case as well. Sorry, 3 cross 8 dimensions. These are of different grid we can have. So again, I had given only the one example here, that 3 cross 8 dimension number of rectangles are 12 in a grid of 3 cross 19. Thank you for watching.